thank you for all joining back here in the middle of your lunch. We want to feed you not with food, but knowledge. And so, the move of developers, what better than to have some developer advocates and customer engineers that work hands-on with developers like you join us and share some of their perspectives on Google Cloud as well as you. So without further ado, please welcome on stage Kristen, Cindy, and Yufeng. Everybody, big round of applause. Sandy, you just finished up the session. Wow, thank you for joining us. This room right here, these are all attendees of not only DevFest, but a lot of you have been here for Google Cloud onboarding and learning the fundamentals of Google Cloud Platform. So we thought it'd be great to hear from you how you all, what you all are seeing with developers. So if we could first have you introduce yourselves, name, and what you do.
My name is Kristen Alamura. I am a customer engineer based in Philadelphia. I help our clients to take and enable various GCDC products. And one of my big focuses is platform as a service.
Thank you, Kristen.
Hi, everybody. My name is Yufeng Guo. I'm a developer advocate based out of New York. I primarily speak about machine learning and big data, though I've been known to branch out and do some dabble in other areas as well.
And if you don't hear enough good ideas from Yufeng today, he will be closing out at the end of DevFestDC. So thank you, Yufeng. And last but not least, Cindy.
So now I know Kristen does platform as a service. I heard that very loudly. So my name is Cindy. I'm also a developer advocate like Yufeng. I'm out of the San Francisco office. I focus mostly on Kubernetes, cloud-native solutions, things like that, containers. I do lots of Firebase on the side. You know, I kind of branch out a little bit. I think all of us like to branch out.
All right. Well, you know, Cindy, if we don't mind starting with you, we start off our onboard session by talking about Google Cloud Platform having this vision of enabling developers to run their code anywhere, whether it's GCP, on-prem, or other clouds. Since you do a lot of work with Kubernetes, can you talk a little bit more about, from a developer perspective, how Kubernetes do that, or some of the other ways we're trying to solve that difficult problem?
Yeah, so I think a big part of our philosophy of Google Cloud is we shouldn't lock you in for any silly reason. We should lock you in because we're the best, right? You want to use us because we give you the most value. So if you build a solution on some custom proprietary technology and you can't leave us or you can't use that somewhere else, you know, that's less of a reason for you to even trust us to start with. So we really believe in open technologies like Kubernetes, like containers, like Docker, things like that. And we don't even want to be the stewards of that. We donated Kubernetes to the CNCF, we created the CNCF, so that we are no longer 100% in control. And instead, the community takes the lead, and the community really brings that project forward. But at the same time, we want to be the best place to run Kubernetes, right? So our teams are constantly innovating on Kubernetes engines, on the other things around it. So Kubernetes runs really well on the cloud. But again, supporting that open source movement, making sure that the Kubernetes we run is Kubernetes, not Google Kubernetes. And so if you want to run on-prem, want to run on other clouds, we really understand that people run their workloads on multiple places, and they don't want to re-architect literally everything to run on multiple clouds on-prem. With Kubernetes and things like that, you have that choice, you have that freedom to run wherever you want, and hopefully wherever you want is on Google Cloud. But you have that choice, and that's really important for us.
Cool, thank you, Cindy. Talking about open source and how it was goal for Google to have that open source to contribute. So to go to you, TensorFlow is also open source and it can run on any platform. It can run in our cloud, it can run locally. But I think everyone would love to hear from you. What are some other ways that the cloud platform is trying to become a great platform for machine learning at scale? TensorFlow is great for machine learning, but what about machine learning at scale on GCP?
Yeah, that's a really good question, Joe. And I don't know how much kind of background the onboard group here has in regards to kind of machine learning and especially the aspect around scaling that up. When I think about running machine learning at scale, it really comes down to there's two major aspects to it. On one side, you have the compute. Right? How do you scale up your machines, coordinate them, distribute the workload appropriately, making sure everything is in sync, and so on. On the other side, you have the question of the data. Right? Doing machine learning at scale implicitly or explicitly means you need to have a lot of data. And both the management, preparation, storage, and retrieval of that data in a way that is fast and at scale is key, right? And coordinating those two. Some of the interesting things that we've seen starting to happen now is the hardware, the compute side, is getting so fast that there are situations where if you're not careful, you can't keep your compute fed. You can't supply data fast enough to actually utilize your complex distributed workflows or distributed training. And so concretely, Google Cloud has the cloud machine learning engine, among other kind of tools that it offers to help developers scale their TensorFlow jobs in this case. For those who are not working with TensorFlow, we also have a bunch of machine learning APIs, both in the form of pre-made ones that you can just call, right? That's easy to scale, and as well as the new AutoML, which right now is just AutoML Vision, but the plan is to kind of allow you to customize the machine learning APIs across the board, not just for images, but also for the other APIs as well. Let's see. Am I missing anything? I'm trying to think. Question. We have compute, storage, out of the box, things that work. And then there's a number of things kind of coming down the road to help further make it easier for developers to use machine learning as an ecosystem and kind of pull in components. So TensorFlow recently launched the notion of the TF Hub, which is basically a network of existing models that you can easily pull in just directly as part of your code and modify, update, trend your own data, things like that. So the tooling is getting better and faster, and it's just a really exciting time to kind of be in this space.
Thank you, Yifeng. Yeah, thank you for bringing up TensorHub, because it's really important asking to the community to help other machine learners start faster with something that exists already. Kristen, going to you. You work with a lot of customers and developers and businesses in the Atlantic. And the people that came on board or have been through the DevFest sessions have heard about GCP. GCP offers a lot of different compute choices, either infrastructure as service VMs, platform as service, App Engine and App Engine Flex, GDGDC. Can you share some thoughts on how you're seeing developers and businesses take advantage of all these different choices? It could seem confusing to some people, but there's a purpose of why we have so many choices.
Yeah, I think one of the great things about the different offerings is it really allows you to choose both your level of operational costs as well as your security requirements. And so we're seeing organizations make some really intelligent decisions. So for example, organizations with less human capital will choose App Engine Standard predominantly sometimes because A, they can stay under the free limit sometimes, and also because they don't have to worry about patching and security, and they don't even have to worry about, oh, have I secured my Apache server correctly based on the newest best practices. And at the same time, that once the application goes live, that person who's the developer can mostly go and develop something new. So there's that kind of core piece that we see really guiding the choices between the platform and the service. But there's this really cool thing that's happened, I think, especially over the last 12 months, and I think Kubernetes has helped drive this idea, especially in terms of service-based architectures, where we're actually combining in a single application multiple different type of compute services so that we can match the needs of that particular service with the strengths of the particular compute. So for example, for incredibly highly scalable customer-facing applications,
Cloud Functions is kind of amazing. Essentially, it's zero ramp. It's as close to zero ramp as you get, I think, of any cloud offering. Conversely, I may have part of that application that really doesn't care when it gets CPU power, and you may actually need to go all the way back to your preemptible instances on compute engine so that you're not paying more money than you need to do that. And I think when companies meld the best of all those pieces into these integrated architectures, they're both saving money as well as providing better solutions for their customers.
Thank you, Kristen. I think you were mentioning to me before that, it doesn't have to be a binary decision. Do I do App Engine or GCD? You may have a monolithic application to take advantage of all these different types of computing in concert with each other. I'm going to put you on the spot, since we just mentioned you. You work with a lot of customers, a lot of developers and businesses locally. Everybody loves a good story, so would you mind sharing with us one of your favorite stories of working with developers, hands-on Google Cloud Platform, and what's something amazing that you've seen them do?
Yeah, well, I recently helped with the proof of architecture for a financial processing company, and one of their requirements was everything had to be serverless. And the use case was they had nightly reports that were coming out in totally free structured text, and they needed to have an opportunity to index and stream that data, well, more batch than streaming, truth be told, in a way that was actionable instead of taking a month to get that data and sort it through in a day. And so they pieced together this amazing proof of architecture that took all the ETL pipeline and put it either on Datarock or Dataflow. They actually initiated most of the rest of the compute by dropping these files into a cloud storage bucket and then using Cloud Functions to kick off the entire process. And it's just amazing to see all these pieces working together, the flexibility, the speed, as well as the ability to easily diagnose individual issues. It was amazing. And they put this together, I think, in 2 weeks. It was awesome.
That's awesome. Cool. Thank you for sharing that. I'm going to go back to Yufeng and Cindy. We also want to open up at the very end for some questions. So if you do have questions for Kristen, Yufeng, or Cindy at the very end, we'll have to open my Q&A before we start the onboard session again at 1 o'clock. But Yufeng, going back to you, this is DevFest, room of developers. Right now, there are more developers in the world than there are machine learners and data scientists. From your perspective, since you work so much hands-on as both a developer and advocate and focus on machine learning, what are some other thoughts you would share with neutral developers about machine learning?
Yeah, that's a really kind of interesting point you bring up around machine learning and data science being, when you zoom out and look at the bigger picture, it is a very niche audience. But I would argue that data science or machine learning, kind of that type of thinking, is in a lot of ways very similar. It feels very similar, this function. It feels similar to both like when the internet first arrived. It feels similar to when mobile happened. During those times, not everybody had to go become a web developer. We are not all, even today, not everyone is a mobile developer. However, we are all heavily impacted by the internet, by smartphones, and we are all very kind of acquainted with those things at the very least, right, if not more so. And so in the same way, I think machine learning or being able to do stuff with your data, because we already are in a deluge of data. That's not going to stop. It's just going to 10x, 100x over the coming years and decades. And so being able to do something useful with your data will make or break your ability to compete, right? In the same way that when smartphones came out, whether or not you had an app, right? Whether or not you could make it to the top of the app store, whether in the internet age, whether you have a mobile website instead of only a desktop formatted website, that would make or break your ability to grow. And in the same way, I think learning how to do even getting the fundamentals around being able to do data analysis of some form, whether or not it's machine learning, is going to be a crucial tool in the kind of developer's toolbox in the years to come.
Thank you very much. I really appreciate your perspective. Data is the new economy, as I would say. Sandeep, back to you. You probably talk to tons of developers, people like this even more, and in particular Kubernetes? What are some amazing things you're seeing with developers in Kubernetes?
Yeah, I mean, so the first thing is just the number of people who use it that you don't talk to and are just happy, how good it is without having to talk to a Googler to make it work, right? You just click a few buttons and it works, and you never have to talk to anyone. It's great. The other thing I hear a lot is like, that's impossible, no. And then they try it and they're like, oh wait, it does work. So I'll give you an example. A big enterprise I was talking to was like, network attached disks can never be that fast. And I said, but it says that on our docs. You want to try it out? They're like, fine. They're like, what? Is that fast? They just didn't believe that we could deliver that kind of performance with that kind of offering, right? And so it's literally like, wow, we have to rethink all of our assumptions because we no longer need to have our own system on top of it. We just use you guys directly. And so we just removed 2 layers of complexity from our stack. Wow, that's freaking amazing, right? That's a very common story because you have to basically change the way using something like Spanner or even our persistent regional disks, which we just launched. It'll write to 2 different regions at the same time. Again, no one else can do this kind of magic stuff, and it makes you rethink how you're even architecting your applications because now you don't have to do a ton of extra work. I think that's a really cool thing. It's not really magic. It's just we have new tools now that didn't exist on an on-prem system, right? And that makes it really cool, and it's make the transition to cloud really interesting because it makes you it's not just a lift and shift, right? You just lift and shift, you're going to do extra work. All cloud platforms, especially Google, have these tools that just make your life so much easier, and I think that is something that I love seeing, that look on their face where they go from, this is not physically possible to oh yeah, let's click the button. Duh, right? That's just amazing.
Yeah, and thank you, Cindy, for bringing up that story. We do, I counter it, we do hear little snippets and stories like that all the time. Another custom engineering team was recently with a network admin, and they're testing out a global load balancer, and they were like, wow, his eyes popped up. I was, wait a minute, your network is so fast. It's because it's ROI and dog shit is big. We do have a backbone. So thank you very much. I do want to open up to questions for everybody in the audience. There are microphones center, to the right, and to the left. If you have any questions for Kristen or Yufeng or Cindy, please feel free to come up and ask questions. We have 5 more minutes before our onboard session starts again. So please feel free to step up and let us know what you're thinking. All right, right there in the middle.
All right, so I just have a question around Kubernetes. It's very new to me, but I've been exploring lately. Just wanted to understand whether Kubernetes can provide those design patterns like circuit breaker, service discovery, those kind of things. Are there any builds, or do we have to program for it, or go for a pattern outside?
So Kubernetes is really designed to be a building block for creating distributed systems, right? So it provides kind of what I would consider the bare bones required to build those higher level systems. So it provides deployments and service discovery, right? And so with those 2 things, you can basically build a lot of higher level systems. And then you have a lot of add-ons and other things in the ecosystem like Istio and things like that provide things like circuit breaking and request routing and things like that. So personally, what I feel is we're right now at a stage where a lot of companies are deploying their stuff directly to Kubernetes. But what we're seeing is things called custom resource definitions and these kind of things that are higher level abstracted things that run on top of Kubernetes that abstract away kind of the mundane management of the actual resources. Like you can get a CRD for Postgres, a CRD for a game server, a CRD for a web server, and it basically gives you create new server, and then it just does it for you versus making a bunch of YAML files and work with Kubernetes directly. So I think what we're going to see is PASs and CRDs and all these kind of more higher level things. So you don't have to ever think about what is circuit breaker. It just is built into that system itself. So I think in the future there's going to be people who are how today we have Linux engineers who really understand the kernel, really understand all that kind of stuff. But most developers really don't. They just write Node.js or Ruby or something, and it just runs somehow. So we still have those people, but we're going to get more and more levels of abstraction. We're still in super early days when it comes to distributed computing. So that's just me looking at it.
Okay. And there's a question on the right.
Hello. So my question is to Christine. She you mentioned platform as a service as a tool. So for Google Cloud, what platform as a service would you recommend, and how does it benefit an engineer in terms of the other platforms as a service out there?
Yeah, I mean, it's really going to depend on whether you're starting from scratch, whether you're moving a piece or all of an application. The really good news from like a DevOps perspective is really all the platform as a service offerings are pretty tightly integrated with various CI/CD pipeline options. And so in that case, you kind of have you covered all the way across the board. So you can kind of take that out of the equation for the most part and really focus on looking at the qualities of your application and the requirements. So like for example, if scalability, speed, security are all kind of the central tenets, but you're willing to make some compromises in terms of being able to bring your own libraries, App Engine Standard would be a great choice. Versus if you have something like, let's say you're doing video processing, a really common need is to go to Flex because you may need the various tools that have to be installed with third-party libraries. So it's really going to depend on your needs and your requirements, and I really highly recommend, we have case studies on the developers' websites for some of these choices about which platform as a service makes the most sense.
Thank you. Thank you, Kristen. And one more question on the right.
Hi, my question is related to data prop. Currently, data prop doesn't have auto-scaling capability. If I am right, can we expect that anything?
Yes. So Dataproc is our Hadoop as a service. So we have Dataflow and Dataproc. Dataflow is what we consider next generation batch processing kind of stuff, and Dataproc is just Hadoop that's hosted by us. The question was, there's no auto scaling for that. Can we expect it? I think they are working on that. So I don't know the timeline, but I think they are working on it.
I would say our ultimate goal is to enable auto scaling into many features and products. I'll just say, reality is Google Cloud Platform is a relatively younger platform compared to some of the public cloud platforms, but our goal is to go as serverless or auto scaling as possible. Thank you very much. One last question.
This is Joe from Velocity. The Google Cloud functions provide a great deal of opportunity. But one of the questions some of our developers are running into is while they're testing things before they're being used at load, say the test time takes a great deal because they're spinning things up and down in between. Is anyone looking at any particular test process that can help speed up how quickly Google Cloud functions can spin up and run? The test environment, and I'm only running 10, 20 things at a time rather than 100.
So just to repeat the question, you're saying you're using Google Cloud Functions, right? And you're spinning up a test environment, and it's taking...
As people are doing development and test, you've got the whole spin up, spin down, because there's not lots of
So you're
things.
deploying your functions to test them, right? So the Firebase folks actually written a really, and our developer relations team have actually written something called a functions emulator. Have you looked at that?
No, they haven't yet. So I'd love to take a look.
Yeah, so there's actually an emulator, and it emulates a lot of the common event types, trigger cloud functions, and things like that. So you can actually just run it in your CI pipeline straight up, without actually deploying.
Okay, thank you.
All right. Well, thank you again, Kristen, Yufeng, and Cindy for joining us and sharing your thoughts and your perspectives from developer advocacy and custom engineering. Thank you, everyone, for sitting in with us during the end of your lunch. With that, we're going to wrap up. Again, happy hour end of the event. We'll all be around. Yufeng will join us to close DevFest. Thank you all for joining us on the panel. Thank you, everyone, for being here. Onboard will start again at 1 o'clock. See you all soon.